This is our fourth example of how we can use the standard normal distribution and z-scores to find probabilities. Now, this particular scenario that we have for this example is more from my specialty area, safety engineering and risk analysis, risk assessment. I think it can illustrate maybe the more serious nature, the more important nature of these analysis methods that we're talking about, how it really is important in the real world to do this type of analysis that we've been talking about in this unit and all the other units. Let me just read this scenario to you. Boeing manufactures a jet with a mean takeoff distance of 4,000 feet. The standard deviation for takeoff distance is 525 feet. Boeing sells this model of jet in small countries where short runway distances, less than 5,000 feet, are common. As part of the risk analysis, Boeing engineers want to know the probability of the jet requiring more than 5,000 feet for takeoff. What is this probability? This probability is important. If the jet takes more than the length of the runway for takeoff, the consequences are not good. The plane can crash, there can be personal injury, there can be fatality, there can be millions of dollars in damage to a multi-million-dollar piece of equipment. None of this is good for Boeing's business. This is an important question, and these are the kinds of questions businesses ask each day. These are the types of questions these are the types of problems that businesses solve each day with some type of quantitative analysis, statistical analysis, data analytics, different engineering methods are used to solve these kinds of problems. Not solving these kinds of problems can be very bad for a business. But this is a relatively simple example, but this is an example of the real-world application for these methods that we're talking about. But let's go ahead and answer our question. What is the probability of Boeing's jet requiring more than 5,000 feet for takeoff? Even though it's maybe a more serious scenario than we worked with previously, the procedure is still the same. We need to calculate the z-score for 5,000 feet. X is 5,000. Population mean 4,000, population standard deviation 525. 5,000 minus 4,000 is 1,000, bring down the 525. Divide 1,000 by 525, we end up with a z-score of 1.90. That is the equivalent of 5,000 feet. Remember, what we're doing with the z-score, we're transforming our original units into a standardized measurement scale. So they are equivalent. Once we have our z-score, we locate the z-score on the normal curve. Once we have the z-score located on the normal curve, we find the area associated with that particular z-score, and it's the area between the location and the mean. Then we can use that to find the probability that we're interested in, the probability of a jet taking more than 5,000 feet for takeoff. So the area associated with 1.90 is found by finding the first two digits of your z-score in the column, right here, then finding the third digit in a row, and where this row and this column intersect, that is our area associated with 1.90. This area can then be used to find our probability. In some cases, that area is a probability, as I've said before, but in this case, we're using this area to find our probability. Once we have that area, we go ahead and shade in the area under our normal curve that's associated with this z-score. And now we're going to subtract this area from 0.5 to find the probability of the jet requiring more than 5,000 feet for takeoff. When we perform the simple calculation here, 0.5 minus 0.4713, we end up with 0.028 rounded to 3 decimal places. We can further round that to 2 decimal places and end up with 0.03. That 0.03 tells us there's about a 3% chance that the jet that Boeing's designed will require more than 5,000 feet for takeoff. Let's put that into more real-world terms. Based on this analysis, there would be 3 crashes for every 100 takeoffs from 5,000-foot runways. That's not acceptable. Boeing can't afford to have 3 crashes out of every 100 from takeoffs involving 5,000-foot runways. That's not good business. That risk is too great. That's not what we would consider an acceptable risk. So Boeing has a decision to make. What could Boeing do? Now, in class, I just threw the question out there and let the class respond. There are several options that Boeing or another company would have if they find that they need to improve the safety of their products to make their products more reliable and more safe for the consumers. One of the easy things Boeing could do is to prohibit use on short runways. They could have a page in their manual that goes along with this jet says not intended for use with runways 5,000 feet or less in length. What normally happens with rules? Now, most people follow rules. Most airport managers and most pilots would follow this rule. But there are also rule breakers out there. Rules are broken. There's the old saying, rules are made to be broken. So simply stating this rule in the documentation that goes with the jet, that's not going to be sufficient. You need a more foolproof measure to reduce the probability of a crash when taking off from 5,000-foot runways. There are a couple of things Boeing could do. They could go back to the engineering drawing board. They could redesign the jet so the mean takeoff distance is 3,500 feet. Standard deviation is still 525, but now their mean is 3,500 feet. Just that change results in a higher Z-score and a lower probability of failure, lower probability of a crash, 0.0022. That would be 22 crashes out of every 10,000 takeoffs involving 5,000-foot runways. Much, much better. But that's not the only possibility. They could redesign the jet so that the system was more consistent and there was less variance. With less variance, they're lowering their standard deviation of 200 down to 250 feet. The plane is operating more consistently. Our mean takeoff distance is still 4,000 feet, but because it's more consistent, it's more reliable, if you will, we have made it pretty safe. Our Z-score goes out to 4.0, and our probability of a crash because of takeoff distance is extremely low. Very improbable that it would occur. So these are the types of responses that a company may make to their statistical analysis. They make the analysis, then they have a decision to make. Then they'll have several options on what course of action to follow. And there are other courses of action that a company like Boeing could follow in this type of scenario. But these are just 3 examples to illustrate the decision-making process that is the culmination of any kind of quantitative analysis.